For three sets A, B, and C, our Venn diagram is going to be a little bit more complicated. And in particular, if we want to draw a generic Venn diagram, we have to be careful how we place that third set. So we might begin with our generic Venn diagram for two sets, and then try and figure out where we might place a third set. But if we place set C here, then this Venn diagram would mean that nothing could be an A and C at the same time. If we drew it this way, this Venn diagram would mean that anything in C must be in B, but can't be in A. And after some experimenting, we find a generic Venn diagram that will work for three sets, and it'll look something like this. For example, suppose B are the things made with bread, S are soups, and M are things made with meat. We can represent these using a generic Venn diagram with three sets. Onion soup, for example, made with beef stock, soup, and bread, is in the intersection of all three. Meanwhile, a hot dog, meat parts on a bun, is not a soup, so it's in the things that are bread and made with meat, and also not a soup. Or consider something like this. We can view this as everything in M together with everything outside of the intersection of S and B. Similarly, this would be everything outside of S intersect B union M, which would be the union of M with the intersection S intersect B, and we want everything outside of this region. And we could try to do the same thing for four sets, but while it's possible to draw a generic Venn diagram for four sets, it's very complicated, so in practice we don't bother. Now, while we can draw generic Venn diagrams for 2 and 3 sets, sometimes we know something about our sets that allows us to produce a better Venn diagram. For example, if we have two sets A and B, but we know that nothing in A is also in B, then the generic Venn diagram would have nothing in this middle region. But if there is nothing in this middle region, we can also draw the two sets as completely separated. On the other hand, if we know that everything in A is also in B, then we can draw the set A entirely inside of B. Or if there's three sets A, B, and C, and we know that A and C have no common elements, then the circles representing A and C can't overlap. But we do have to allow for the possibility they overlap with B. And so our third set, B, should be drawn something like this. And what if we have four sets? If the elements of D can overlap with at most one of A, B, or C, but A, B, and C are otherwise unrestricted, then we could start with our generic Venn diagram for three sets, and we need to draw a fourth set so that it can be in A or B or C separately, but it can't be in any of these intersections. And so after some thought, we might end up drawing something like, well, how about this? And so here we have a fourth set D, which could also be in A or B or C individually, but there's no way that something can be in D and be in more than one of these other sets. For example, let P be the set of people who eat pork, C those who eat chicken, B those who eat beef, and V those who are vegetarian. Since vegetarians don't eat pork, chicken, or beef, then the set V should be disjoint from the other three, so we can draw a generic Venn diagram with three sets, then draw a fourth set separate from these. Someone who eats beef and chicken but not pork would be in B union C intersect P complement. We could form this region by starting with everyone in B or C, but then remove the portion that's also in P. Finally, someone who eats fish but not beef, chicken, or pork is outside all four sets. So they're not in V, and also not in B, and also not in C, and also not in P. So we can describe them as being in the intersection of four complements.